Hello and welcome to another session. In this session also we will solve few very important questions. Let's take the first question. Find the foot of perpendicular from point P 1, 2, minus 3 to the line x plus 1 upon 2 equals to y minus 3 upon minus 2 equals to z upon minus 1, and also find the image of P in this line. So it is clear that there is a line, say this is the line, and here we have a point whose coordinates are given 1, 2, minus 3. A perpendicular is dropped from this point to the line. Say Q be the foot of the perpendicular. We have to find the coordinates of point Q and also the image of this point P above the line, say P dash. Suppose its coordinates are x, y, z. So we have to find the values of x, y, and z also, and the foot of the perpendicular, that is point Q. So let's start the solution. The equation of line is x plus 1 upon 2 equals to y minus 3 upon minus 2 equals to z upon minus 1 equals to lambda. Let's call it lambda. Now, any point on this line is given by 2 lambda minus 1 comma minus 2 lambda plus 3 comma minus lambda. So this is a general point. This is a general point on the line. Now PQ is a vector. Let us find the position vector of PQ, which is 2 lambda minus 1 I cap plus minus 2 lambda plus 3 minus 2 j cap plus minus lambda minus of minus 3, that becomes plus 3 k cap. That is, this is 2 lambda minus 2 I cap plus minus 2 lambda plus 1 j cap plus minus lambda plus 3 k cap is the position vector of PQ. Now, since PQ is perpendicular to the line, since vector PQ is perpendicular to the given line, so we have 2 times 2 lambda minus 2 minus of 2 times minus 2 lambda plus 1 minus 1 bracket minus lambda plus 3 equals to 0. This is the condition of perpendicularity, or this on further simplifying will give 4 lambda minus 4 plus 4 lambda minus 2 plus lambda minus 3 equals to 0, which is nothing but 4 lambda, 4 lambda and lambda. This is 9 lambda minus 4 to 6 and 3 minus 9 equals to 0, implying that lambda is equal to 1. Let us put it in a box. Now we got the value of lambda, and this is a general point. General point on the line. General point on the line means any point on the line, depending upon the value of lambda. Lambda can have any value. Now for this particular value, this will be the foot of the perpendicular. Now therefore foot of perpendicular is, we will put the value of lambda in this point, 2 times 1 comma minus 2 times 1 plus 3, this is minus 1 and minus 1, that is 2 minus 1 is 1, minus 2 plus 3 is again 1, and this is minus 1, is the point P, point Q, point Q. Now we have got the coordinates of this point Q as 1 comma 1 comma minus 1. Now we have to find out the coordinates of P dash, which is the image of point P. Now for this, let P dash x comma y comma z be the image of P in a line. So Q is the midpoint of PP dash. Q will be the midpoint of P dash, as the image is formed as far behind as the object is in front. So now using this information, we can easily calculate, that is x plus 1 on 2 is 1 and y plus 2 upon 2 is again 1 and z minus 3 upon 2 is minus 1. This gives x equals to 2 minus 1 is 1, y equals to 0 and z equals to minus 2, that is plus 1. So P dash is 1, 0 and 1. This is the image of point P. Let's take another problem. Show that the line x plus 1 upon 3 equals to y plus 3 upon 5 equals to z plus 5 upon 7 and x minus 2 upon 1 equals to y minus 4 on 3 equals to z minus 6 over 5. Intersect. Also find the point of intersection. Let's start the solution. Let x plus 1 on 3 equals to y plus 3 on 5 equals to z plus 5 upon 7 say is u, and for the second line x minus 2 upon 1 equals to y minus 4 upon 3 equals to z minus 6 upon 5 equals to v. Then general points on these lines are 3u minus 1, comma 5u minus 3, comma 7u minus 5 and v plus 2, comma 3v plus 4, comma 5v plus 6. So these are the general points. Now since lines intersect, that means this is a general point, and at the point of intersection these 2 points will have the same coordinates. Then they will intersect if and only if 3u minus 1 is equal to v plus 2, which implies that 3u minus v is equal to 3. Let us call it at 1. And next is 5u minus 3 equals to 3v plus 4. This will imply 5u minus 3v equals to 7. Let's call it second equation. And 7u minus 5 equals to 5v plus 6, which gives us 7u minus 5v is equal to 11. Let's call it as 3. Now solving equations 1 and 2, we get u equals to 1 by 2 and v equals to minus 3 on 2. Now let us put these values in equation 3. Putting these values in equation 3, let us check it. It will be 7 times 1 by 2 minus 5 times minus 3 on 2, which is 7 on 2 minus minus plus 15 on 2. This is 2 in denominator, 7 plus 15, and this is 22 on 2. On cancelling gives us 11. So the lines intersect. Thus we have proved that the lines intersect, and the point of intersection is 1 by 2 comma minus 1 by 2 comma 3 by 2. This gives us the answer. Thank you very much. We shall continue solving few more important questions. Stay healthy.